Hello, and we are now on the lecture 2 of our class. Now, our topic for today is all about the errors and statistics and analytical chemistry. Now, sir, bakit po ba merong statistics sa may analytical chemistry? Now, analytical chemistry kasi, as discussed in the last lecture, is all about chemical analysis. Now, when in terms of an analysis, makapag-obtain ka ng data when you are doing an analysis. Now, kaya meron tayong statistics kasi it involves the application, kung paano nyo ititreat yung data, kung paano ninyo i-interpret, and how do you show the data, and using the data and manipulate it. So, paano ba mangyayari ito? Now, the outline of our discussion is puro tayo computation dito, guys. So, I am requiring you to use a calculator. Siyempre, hindi naman tayo makakapag-calculate kung wala tayong calculator. And ang recommended ko is scientific calculator dapat. And there are protocols to follow here para mas mapadali ang inyong calculation. Pero i-search na lang sa YouTube ang mga calculator na ginagamit nyo. Now, let's go on to the discussion proper. The objective of this is we should be able to familiarize with the precision and accuracy, propagation of errors, F-test, T-test, Q-test, and etc. Now, let's go on to our discussion proper. Now, what is the difference between accuracy and precision? Dun sa may accuracy, meron kayong standard value na sinusundan na kung saan yung measure ninyo is i-compare nyo ninyo doon. Kaya nga ang definition niya is the agreement between a measured value and the standard value. Now, dun sa may precision naman is wala tayo ditong standard value na given. So, therefore, measure ka lang ng measure without even having a standard value to be followed. Now, there are characteristics of accuracy and there are two, including reproducibility and repeatability. Ano ba ang reproducibility? Ang reproducibility in precision is the agreement or closeness among the measured value between runs. Between runs yun, guys. So, kailangan nating makuha natin kung ano ba ang difference nun. Next is the repeatability in precision. Is the agreement or closeness among measured values within the runs. So, within the runs. Now, ngayon, as is illustrated here in the dartboard, kung mapapansin ninyo dito, this one here, kung mapapansin ninyo, is masyadong scattered yung ating mga data. Now, ito ay merong low accuracy and low precision. Dito naman sa may isa is meron tayong andito, meron tayong low accuracy and high precision. Sir, bakit po low accuracy? Kasi nga, hindi naman natin nahihit yung bullseye. Now, the next is the high accuracy and precision. Paano ba natin makakuan yan is ito, high accuracy and low precision. Bakit high accuracy? High accuracy. Kasi nga, malapit siya doon sa may bullseye natin. The measured values are almost close or not so close in the bullseye, but the data are scattered. So therefore, high accuracy and low precision. And next, ito naman, ang pinakamalupit na measurement na matatsambahan natin is ito ay high accuracy and high precision. Bakit ganun? Kasi kaya high accuracy, kasi the measured values are on the bullseye, and the high precision naman natin is nandoon sa micron natin, ay magkakadikit. Okay, next. Now, ito naman tayo, ways of expressing accuracy. Now, I think there are only one formula, there are two formulas involved in terms of expressing accuracy, and that is the absolute error and the relative error. Ang formula lang naman ng absolute error is the absolute value of measured value minus the standard value. Since it is an absolute value, so therefore, it will always give a positive numerical value. Sa relative error naman is nadagdagan lang siya ng over standard value times the 100% or the ratio of absolute error and the true value, usually expressed as parts per thousand. So ito yung formula natin. Now, punta naman tayo in terms of ways of expressing precision. Now, this one here, our number one formula. Our first formula is denoted by D, and then may hat doon. is given by the equation of individual data or xi minus the mean all over the number of population. That is D. And then next, the standard deviation actually is denoted by S. And ang formula is the square root for the summation of individual data minus the mean is squared. So therefore, it will always gives a positive numerical value all over the number of population minus 1 if and only if the population is less than 30 or data, as I should say, is less than 30. Now, if the data is greater than or more than 30, you're now using this standard deviation, or ang pagkakaiba lang naman nila guys is yung denoted. This one is S and this one is, I think, sigma. Sigma yata ang letter nito sa may Greek letter natin, if I'm not mistaken. Now, next naman is the variance. Ganito lang naman ang variance. Is tatanggalin nyo lang yung square root ng ating standard deviation. Kaya nga siya na-express sa may S squared. Kasi nga, in order to cancel out the square root of the formula. And this is applicable if the population is less than 30. And for this, another symbol for variance is just ito, mag-cancel lang, if the population is greater than or equal to 30. This is a typographical error. I-correct na lang po, guys. Okay, ako na. I-correct dito. Symbol. Okay, maubusan tayo ng oras. Pa-i-correct na lang, guys. Dito, okay. Next, coefficient of variation is also known as the relative standard deviation. Kasi nga, it is the ratio of standard deviation all over the mean of data. 5 is the range. It's just a absolute value of the highest value minus the lowest value of your obtained data. And then, punta naman tayo. So, therefore, ito na. There are 5 formulas in terms of expressing precision. Now, punta na tayo sa my confidence limit. It is denoted by mu, also known as the confidence interval. It is the range where the standard value lies and is equal to mu, mean, positive, negative, where S times the T, standard deviation times T all over the square root of population. Sir, ano po ba ang value ng T natin? Ang value ng T natin is makikita dito, depende sa may number of population natin, or N-1, degrees of freedom. And ayan, depende. So, it is always a constant value na nakadepende dun sa may percentage, the confidence level, and the degrees of freedom. Mamaya maka-encounter tayo ng mga example dyan na magagamit niyo yung mga formula na yan. Okay. Next. So, ano ba ang purpose? Okay, next. That's the confidence limit. Next is the Q-TES. Wow, Q-TES. Sana all cute. Okay. Dito naman, it is involved the rejection of the outlier. Sir, what is the outlier? Yung outlier na yun is yun yung for example, you are obtaining 3, 3.1, 3.2, 3.01, and then bigla kayong may na-obtain na data na 9. That is the outlier. Now, dun sa may data na yun, hindi niyo siya basta-basta pwedeng tanggalin or dugasin na dayan yung data, but rather gagamit kayo ng Q-TES in order to reject that outlier. Okay, and may formula iyon. Ngayon, ito naman, may formula siya, which is ito, the Q-cal. Now, ano bang cases dito? If the Q-cal is less than the Q-tab, ano ba yung Q-tab na yun, sir? Ito yung Q-tab natin. Depende yun sa may number of observation and confidence level. And yung Q-tab, the suspected outlier is retained. So, if the Q calculated is less than the Q-table, value in the Q-table, so therefore, the outlier is retained. I-retain din nyo yung 9 na yun, kahit gaano kalaki ang difference niya doon sa may mga na-obtain yung data. And then, if the Q calculated is greater than or equal to the Q table, the suspected outlier is rejected. So therefore, the suspected outlier ay tatanggalin ninyo agad-agad. So may mga ganun pala, sir, hindi pala tayo pwede magpan agad ng data. Hindi pala pwede tayo magtanggal agad kahit na malayo yung value niya. But rather, gagamitin nyo siya ng Q-TES. And ayan. Now, exercise problems, guys. We will tackle this on the part 2 of our lecture kasi mauubos ang oras natin. and I only have 40 minutes to discuss. And ito na. So may mga sagot na rin, wow, sir, di na natin na-solve ito kasi may sagot na. Hindi, dapat alam mismo ang solution dyan. Okay, that involves my part 2. Daming problema naman ito. Okay, kaya naman natin yan. Don't worry, guys. Okay, punta muna tayo sa mga discussion bago tayo magkaroon ng mga sample problem. Now, the errors. Siyempre, sa may mga experiment natin, wala namang perfect na analysis guys. You will always encounter an error. And there are two types of error. Ano ba yung ibig sabihin ng error? It lowers the accuracy of the obtained data from our experiment. And ma-appreciate mo itong mga to guys kapag nagtitesis na kayo or gumagawa kayo ng special project. Now, it can be determinate or indeterminate. Okay, from the word itself, indeterminate, na-determine niyo yung sources of error. And indeterminate is mahirap i-determine or worst case scenario, hindi niyo ma-determine yung sources ng error na nanggaling doon sa may experiment niyo. Now, ano ba yung determinate error? It is also known as systematic error that can be detected and corrected. So, nade-detect pala siya. That's determinate. Saan ba yun? Saan ba nagmumula ang mga determinate errors natin? Maaaring na dun sa equipment or yung ako or tayo na gumagawa ng analysis and the experiment design. Kasi mali experiment design natin, nagkamali tayo ng input sa may schematic diagram. Kaya nagkaaganon. Now, next naman, sa determinate error can be instrumental, personal, or method error. Sa may instrumental error, it's doon sa may faulty or uncalibrated equipment. Doon sa may personal operative error is doon ang gagaling sa atin. Maaaring nagkamali tayo ng calculation, nagkamali tayo ng estimation in the measurement, incomplete trying, and transfer of solutions. Now, doon naman sa may method error, ito yung pinaka-serious kasi nga, ito yung most unpreventable na pwede mangyari. Kasi, for example, dun sa may nag-analysis tayo, suppose we are performing a gravimetric analysis, is maaring doon magkaroon ng precipitation of impurities, yung incomplete dissolution ng precipitate or side reactions na pwedeng maka-effect or mag-interfere doon sa may results natin. Now, doon naman sa indeterminate, it is a random error kasi nag-a-arise siya from the uncontrollable variable in the measurement. And it is always present and can never be corrected. Okay, there are three types ulit. Personal, instrumental, and method error. Sa may instrumental is variation in line voltage. Kaya nga yung mga equipments natin is meron tayong AVR or automatic voltage regulator para hindi magkaroon ng variation yung measurement natin. And doon sa may personal and operative error is misestimation of the meniscus, maaring doon sa may glass wares or doon kung tayo ay color blind. Mare-resolve naman yung color blind is patingin niyo siya sa may taong hindi color blind. And saan ba natin ma-encounter yung color blind analysis? Doon natin siya ma-encounter sa may qualitative analysis. Now, next is the method error. Now, dito nagkaaroon ng variation dahil doon sa may environmental conditions like humidity, temperature during the measurement or analysis. Sir, bakit po ba nagkaaroon yan? Kasi nga, humidity or moisture natin is na-affect doon sa may weight. Kapag mas malamig, mas mabigat yung sample. Kapag mas mainit, mas magaan. Kasi nga, dahil doon sa may mga naka-absorb na water sa surface ng ating sample during the analysis. Now, another one is the propagation of errors. Now, saan ba nanggagaling ang propagation of errors? Nanggagaling ito sa may several deviations of the instruments used in the conduct of measurement and analysis. Let's say, involves a calculation, pag-transfer ng mga titrant sa may burette, and pagsamsam na yun, pagsamasamahin ninyo, and various depending on the complexity of the operations used to get the measure propagation of errors. And here are the formulas na magagamit natin sa may propagation errors. Now, don't worry guys, you don't have to memorize these formulas kasi often formula naman tayo. Kaya magagamit nyo din naman yan. And besides, hindi naman tayo magkakaroon face-to-face classes. So, hindi ko rin malalaman kung gagamit any formula o hindi. Now, exercise problems will be tackled in part 2. So punta na tayo sa may test of significance or F-test. There are two actually tests for significance. Ano ba ang purpose ng mga test na ito? Ang purpose ng test na ito, guys, is to determine whether there's a significant difference between the method that you are used to the existing method. Now, ang formula nito is just here. FCAL is just the standard deviation of data number 1 square all over data number 2, where S1 is greater than S2. Now, ito naman ngayon is pareho lang siya ng Q-test natin. Used to determine whether there is a significant difference between the results of two different methods based on their standard deviations. And it's performed by comparing if the FCAL is equal or greater than or less than or equal to FTAB, the methods are not significantly different. And if the FCAL is greater than the FTAB, the methods are significantly different. Sir, saan po ba nakikita yung FTAB na yan? The FTAB is makita ninyo dito. Depende sa kanyang confidence level. Now, I will attach the 90% and the 99% confidence level sa i-attach kong PDF file, kaya malalaman ninyo kung ano bang ginagamit natin. So, this is one here. The FTAB is at alpha and N1 minus 1, N1 minus 1, and N2 minus 1. So, ayan yung magiging kwa natin. Next test is ito, exercise problems. We will skip this part kasi doon na siya sa may part 2 ng ating discussion. Now, T-TES naman is used to determine whether there is a significant difference between the results of two different methods. One is the accepted method, while the other is the test method. So, two different methods, difference between the results of two different methods. So, ano bang difference niya sa ating F-test? Now, ito kasi is same lang sila, pero dito kasi nakadepende lang doon sa may standard deviation, while the T-TES is nakadepende doon sa may mga means and the standard deviation of the data obtained from your analysis. And same principle din, TCAL, if the TCAL is less than or equal to TTAB, the methods are not significantly different. And T-calculate, if T-calculate is greater than the TTAB, then the methods are significantly different. So here, ito yung mga T values natin according to their confidence level and degrees of freedom. So there are three cases when involving a T-test. When the other is an accepted values known and when comparing means of two methods used on the same sample. So dito sa may case letter B, kailangan niyo mag-F-test muna bago kayo mag-proceed sa T-test. And they had their own formulas. And C, when comparing means of two different methods used on two or more samples. So more samples ang magaganap din yan. So when an accepted value is known, the formula is just a X or mean minus the confidence interval times the square root of the number of population or data and S. And the TCAL is this, and the TTAB is the alpha, and degrees of freedom is N minus 1. And when B naman, kailangan niyo mag-F-test muna. F-test muna. Now, dito, there are two processes here. When case 1, when is statistically the same, the case 2, when is statistically different. Now, for case 1, let's say, for example, yung F-test ninyo, ang naging result ninyo doon is statistically the same daw yung methods ninyo. Ito yung gagamitin niyo yung formula. Where TCAL is the absolute value of mean 1 minus mean 2 all over the S pooled times the square root of N times N2 or the data number 2 all over N1 plus N2. And yung S pooled natin is ito yung napakahabang part na formula natin. It can be expanded into standard deviation of data 1 squared times N1 minus 1 plus standard deviation of data 2 squared times N2 minus 1 over N1 plus N2 minus 2. So, ganun ang magiging pan natin. And ito yung expanded form niya. And guys, when you are looking at the T-tab, it involves a N1 plus N2 minus 2. If and only if yung kan natin, yung letter, ginagamit natin test is letter B. Paano naman kapag magkaiba based from your F-test? Ang mangyayari dito is, kapag daw statistically different, ito yung gagamitin ninyo na formula. Where TCAL is equals to the absolute value of mean 1 minus mean 2 all over the square root of standard deviation square all over N1 plus standard deviation of data 2 squared all over N2. And when comparing means of two different methods, use two or more samples, ganito yung magiging formula niya. Ayan yung mga magiging formula natin. So therefore, to wrap up our discussion, the F-test only involves the formula. And there are problems exercises here. Ayan, doon kasi nagtatapos yung topic natin. Pero yung mga sample problems natin dito will be solved on the part 2 of our lecture. So to wrap up our discussion, the T-TES therefore are yun yung pinakamahirap na calculations natin. Kasi it involves a 3 cases. Case 1, tapos dito sa may case B, mahaba pa ito, gagamit kita ng F-test. And C, when 2 or more samples are used. And then the F-test naman, kapag F-test lang, when you are comparing two methods, gagamit lang kayo ng standard deviation ng samples nila. So, I will end my discussion here and magkita tayo sa may part 2 ng ating lecture.